What about a problem like this? 3/4 times 2/3. Ooh, we're fast this time. Take a minute to think. Devin, are you thinking?
Mm-hmm.
Yeah? Do you want to try this one?
No.
You sure? Okay. Let's see. How about Kamani?
6/12.
6/12. Okay, let's see. I'll start with my good old array. What should I start with, Kamani?
Same as the 4.
Why 4?
Because the denominator is 4.
Mm-hmm. Okay, so I'll cut it into 4ths. I want to show 3/4. How can I do that, Rebecca?
You color in 3.
Okay.
Like blocks.
3 blocks. Showing 3. I'm going to use our notation. 3 out of 4. Now I want to show 2/3 of the 3/4. Nicole, what would I do?
Cut the box in the whole box in 3,
Okay.
and then shade in two boxes,
2 boxes.
like you know how you did with the 1/4 times 2/3, how you shaded in 2, you do the same thing.
Mm-hmm. I'm going to do that again. Huh. Okay. What does that tell us? Kamani?
That is now 2/3.
That is now 2/3.
What you just shaded.
Ah, you're right. Let's notate it. So let's think about this as 2 out of 3. How does that help us? Yeah. Amanda?
I'm actually kind of confused on how it's 2/3.
Yeah.
Okay. Let's back up for a second. Where do we see the 2/3? Felicia?
Going across.
Going across. So if you think about it as a third, and a third. In fact, I could do that. This is a third. This is a third. This is a third. I colored in kind of green this third and that third. 2 out of the 3 pieces, 2/3. There's a little bit of overlap. Notice the overlap is in this section right here. Here's the overlap where they've been shaded by the 3/4 and they've been shaded by the 2/3. How does that help us, Felicia?
Okay. That let us know that it's 6. The parts that shaded in is 6/12 of that, because the whole thing is 12, and there's 6 of them shaded in with the overlapping.
The overlapping part. So really, 2/3 of 3/4 is this section right here, right?
Yeah.
Abia, say more about that.
You could reduce it.
I could reduce it. What's another name?
1/2.
1/2. Do you see in the picture how this is 1/2? Where do you see it?
Well, I say it's 3/4.
Uh-huh.
That's 12 and everything. And there's 6 colored overlaps. So that's
Okay.
6 and 6 now.
Okay, I have one more for you. Here's one. What happens if I do this? What happens if I do this? 2/4 times 3/3. Think for a minute about this. Maybe this isn't as complicated. Louis, what do you say about this one?
It's 6/12.
It's 6/12. Okay.
Like it's 3 and 3, so
3 3s is 1. So another way to think about this problem is 2/4 times 1. What's 2/4 times 1? Same measure? It's a half. Huh, interesting. Is there a connection between this problem and another problem we've done? Nestor? It's the same answer as the other one. What happened between this problem and that problem? See if you see a connection. Rodney?
It's the same thing because 2/4 is like a half, and if you do 2/4 times a whole, which is 1, which equals 2/4, which is the half, and the other problem with 3/4 times 2/3 equals 6/12, and 6/12 is a half, so it's like a string.
It's like a string. Okay. I noticed that in all of these problems, I hope you noticed I used fourths and thirds. In this problem, as numerators, I used a 2 and a 3. And in this problem, I used a 3 and a 2. But I did something different. Did you see what I did? Dale?
From the problem that you just said before, if you look diagonally, like diagonal across from it, you could place the 2 where the 3 is.
I could place the 2 where the 3 is.
Yeah.
I did some switching, huh?
Yeah.
Lewis,
What
what
the numerators?
I flipped the numerators. That's a nice way of saying it. I actually kept the denominators the same. So we know we're going to have a 3 by 4 rectangle, and I flipped the numerators. Let's draw an array and see what it looks like.